In this video we shall discuss how to use triggers to update caching tables and fields. In the first task we have to modify subscribers table to store the last visit date for each subscriber and keep the data up to date. After the task completion, this table should have such a column and that column should store that data. Let's start with MySQL, and first we have to modify this table to add that column to store that data. Then we have to initialize the data. It asks we have to execute such a query to find out the last visit of each subscriber and to update that information in subscribers table. Now we have to deal with triggers. First let's drop old versions, then we have to switch the delimiter of SQL queries, and now we may create triggers themselves. We are starting with the trigger that reacts to insert operation on subscriptions table. To speed up the query, we modify only the subscriber with the new visit date, so this is the condition for that operation. And we may also check, do we really need to update anything at all? We only need to perform that update if the new visit date for a subscriber is greater than the previous one. And of course, as cascade operations do not activate triggers in MySQL, you'll have to create some more triggers on books table yourself. But why this table? That's because if a book is deleted, some information may be deleted from subscriptions table, and those records may contain the latest dates for some subscribers. With update trigger, the approach is really the same. We only take into account the information about modified subscriber, then we calculate the last visit date for that subscriber and we use that information to update that field. And we follow the same approach in delete trigger. We are only taking into account the records with modified subscriber ID, we calculate the last visit date for that subscriber and we use that information to update that field. And of course now it's a good idea to test all those triggers performing corresponding operations, so please execute all that code to create triggers and write some queries to test that triggers. And we are continuing with Microsoft SQL Server. Here we also have to modify our table and initialize the data. But the next part of solution for Microsoft SQL Server has several differences from solution for MySQL. The first difference is that in Microsoft SQL Server, triggers are activated by cascade operations. That's why we only need these triggers and nothing more. And the second difference is the next. As Microsoft SQL Server does not support row-level triggers, we may follow this not so efficient but rather simple solution. Each time we are recalculating the whole data set and use that information to update the whole subscribers table. This approach is slow, but it's really simple. And of course, in Microsoft SQL Server we may use the same code for all three operations. And now, of course, it's a good idea to test this trigger performing corresponding operations, so please write such queries yourself. With Oracle we also have to alter our table and add such field into that table. Then we have to initialize the data and then we have to create triggers. In this particular case with Oracle we are following Microsoft SQL Server solution. We're using that slow but simple idea and we use the same trigger for insert, update and delete operations. But because Oracle supports row-level triggers, you may rewrite this solution yourself following MySQL approach. And of course don't forget to test all these triggers performing corresponding operations, especially test your own solution. In the second task we have to create such average table to store the following up-to-date information. We have to store average value of books count for taken by a subscriber, then we have to store average value for days count for a subscriber keeps a book, and then we have to store average value for books count for returned by a subscriber. The expected result may look like this. Here's our average table and these our three fields to store that data. Let's start with MySQL, and first we have to create our average table. Then we have to truncate this table, because we really do not know how many times shall we execute this query or some other queries and so on. So it's a good habit to keep all tables clear in case they have to be clear. Then we have to initialize the data. While this query is rather huge, it's simple. We only have to count several values to sum several values, and then we only perform simple mathematical operations to calculate those average values. And now we shall create triggers starting with MySQL. As usual, first we drop old versions of our triggers, then we have to switch the delimiter for SQL queries, and here is our first trigger. This one reacts to insert operation on subscribers table. The trigger body contains almost the same query as for data initialization. The only difference is for initialization we were using insert and here we are using update. And of course, as cascade operations do not activate triggers in MySQL, you'll have to create some more triggers on books table and maybe on some other tables. Also, please pause the video and think, do we have to create the update trigger here, or we only need the insert and delete ones? This is the answer to the previous question. Of course, we don't need the update trigger here, as subscribers update doesn't influence any data of interest here. So we only have to create the delete trigger, and the trigger body is exactly the same as for insert trigger. But as this data depends not only on subscribers table but also on subscriptions table, we have to create several triggers on this table also. Once again, let's drop old versions of triggers, switch the delimiter and start with the trigger number 1, the trigger that reacts on the insert operation on subscriptions table. Because each time we have to calculate the same data, the same information, this trigger body is exactly the same as for previous two triggers. And for update trigger, its body is exactly the same as for all previous triggers. We only have to create several triggers with exactly same bodies because MySQL does not allow us to associate one code, one trigger with several operations. So obviously the delete trigger body is exactly the same as with previous triggers. And that's all for MySQL. Now it's only a good idea to test all those triggers performing corresponding operations. The first step for Microsoft SQL Server is exactly the same as for MySQL. We have to create the table, we have to truncate the table, and we have to initialize the data. Because Microsoft SQL Server allows to associate one trigger with several operations, we only have to create one code here and associate it with insertion and deletion of subscribers. Please remember that we do not need an update trigger here because subscribers update doesn't influence that data. But we have to remember about subscriptions table because modification of data in that table influences that data. So once again we are using Microsoft SQL Server ability to associate one trigger with several operations, and that's why we only have to write this code once. And that's all, so now it's a good idea to test this solution, so please write corresponding queries yourself. And as one may easily guess, the solution for Oracle is exactly the same. We have to create our table, we have to truncate it, we have to initialize the data, and we have to create several triggers. As Oracle also allows to associate one trigger with several operations, we only have to write this code once. And unlike with MySQL or Microsoft SQL Server, we may use merge operator here with such a condition, and that will allow us to speed up the process a little bit. For subscriptions table modification, we also have to create only one trigger and associate it with insert, update and delete operations. But the trigger body is exactly the same as the body of the previous trigger. And that's all. Now please write corresponding queries to test this solution.